So this video is going to be a summary of all the testing I've done on the MTR105 here and comparing it to the package of the U1461A and the MetraHit Coil there. Those instruments were chosen because I tend to use them a lot when I'm testing out electrical motors before I purchase this MTR105, and they also come out together at around about the same cost based on UK recommended retail prices. So I'll put up a table of the overall scores, and you can actually see that the combination package does score out the same as the overall scores for the MTR105. As with all these things, you tend to find instruments have their own individual benefits and do some things better than other instruments on the market can. With regard to the MetraHit Coil, this brings good current measurements, capacitance, and it is the most economical with regards to battery life. The U1461A, that's got some pretty good accessories with it. I also like the way the accessories are laid out within the case. It's a much easier case to get the bits and pieces out of. Its insulation testing function is more accurate than either of these two instruments. And of course, with that instrument I can get a complete polarization index curve stored. The downside to it is I have to have a laptop with it and connect it to the laptop to get it to do that, but that functionality is there for me, whereas it's just not on either of these other two instruments. With regard to the MTR105 itself, it gets most of its points really from having extended functionality, and you can see this when it boots up on the voltage function here. Obviously all three instruments have the ability to read AC DC volts. The MTR105 tends to get the better of the other two instruments because you can extend it beyond your AC there, your DC there, but then you get this three-phase mode built into the MTR105, and it will give you phase sequence as well as the actual phase-to-phase values that are measured there. Neither of the other two instruments have that, so if that's something that you find a need for, the MTR105 can provide that. When I had this measuring the output of an inverter, it wasn't very happy. Did kind of semi-solve that by building up a little filter box here that you can put and plug into it, and then with that it will measure the output of the frequency inverter and will give me the phase rotation as well. So it's not brilliant, it's solvable. Megger might come out with a solution to it. I just don't know, but that is one issue that I do have with the instrument. If you go to insulation testing, I can mount to 500 volts. So that's your insulation testing function on this. It doesn't look like it. This instrument always defaults to the voltage mode as the main display to show there's no voltage there. But you just have, this doesn't have any functionality whatsoever other than a spot test. This U1461A does have time mode, DAR and Pi mode, and as with the MTR105 it also has all of those. You have Pi mode there, time mode there, DAR mode there, and extra functionality within the IR spot test mode is to enable a temperature compensation function. Again, neither of those two instruments have that, so if you wanted to, as opposed to doing the calculation mathematically after you've taken the readings, this instrument will do it for you and you'll get that stored value, but it'll only do it when you're in spot test mode. It won't do it in timed mode. So again, this we've got the standard ranges on here. This doesn't have 100 volts, but you can pick up 100 volts from the variable function. The MetraHit does have all the test voltages, but it's set via the selection switch here. You'll just see it change at the top here, hopefully. It can only go one way. There's your 50, 100, 250, 500 and 1000 there. Obviously with the U1461A you can select it on the rotary switch. There is a variable voltage on this, but you have to get to it via the setup menus, and it's a bit of a okay, so there they are there. What you have to actually do is look at the voltage level that you want and set it within the boundaries of the menus that are there. So if I wanted to set this to 150 volts, I would go down to the 250 volt range, edit that, select it to voltage, and then I can change these digits here. Oh, it's 150, didn't I? Let's go. So it is limited in actual fact. So I won't be able to get 150 volts from that range. Let's see if I can get it from the 100 volts. Okay. So it's not a full variable voltage. So that's how you try and set it up on the U1461. It's quite an awkward way of setting it, and you can't get a full set of voltage ranges that you can on the MTR105. To menus, to set it on this, you just merely swing this around to the settings, and you just fade your way down to the variable voltage function, hit the go on that, and then you just set it around to this, and you can set it wherever you like. There's a 150 there, easily set. And once you've set it, save it, save there, and then you can go back to the voltage function, and there's the 150 volts. I find this instrument much more user-friendly than either of the other two instruments in actual fact. It just suits the way I think. As you go around here, got an ohms testing function. This does kind of match the 200 milliamp test function, as same as the MTR105, but does it via an earth bond, and then it's got a normal ohms function that does actually have a better range than this instrument. With this, the MetraHit Coil doesn't have a 200 milliamp measurement function, so just a standard ohms range function. And again, where the MTR105 starts to get the better of the other two instruments is in its submenus. You've got a bidirectional test there, which neither of the other two instruments have. And also I can flick him round. We've actually got a 4-wire function, again with bidirectional or unidirectional test, which neither the U1461A or the MetraHit actually has. Moving around, we've actually got motor direction of rotation, unique to the MTR105. Neither of those two other instruments can compete with it. And then we've got the LCR function, which can have capacitance, which obviously the other two instruments have, but it also has inductance, which neither of those two instruments have. So again, it gets one better, and it does have a temperature function in here, which both of those two instruments do have. They have temperature here, and I'm sure he's got temperature somewhere. Yeah, off of there. And then page through. There you go. So all three instruments have a temperature function available for them. Memory wise, the one thing I do like about this is that you take this unit out on its own and you just save all the data to a memory slot, which you can actually name, so you know what motor you've tested and you know the tests that have gone to this one, and then you just download it to a USB and take the USB to the computer. Both of these two units have a little bit of onboard memory, but to get the most out of them you have to have the computer with you and save the data to the computer as you're doing the actual testing. The one advantage of that is that both of these two instruments can give you logging function, whereas the MTR105 doesn't have any logging whatsoever. So with regard to the accuracy of the instruments, I put a table up showing the overall accuracy of all 3 meters. The most accurate is the U1461A at coming around about 0.5%. The MTR105 is 0.75%, and the poor old MetraHit is miles out at around about 14%. That's mainly due to part of its insulation testing function, and it's the actual current capability output at the 1000 volt test level doesn't match the IEC standard, so it's miles out in comparison to the other two instruments. I've tried to do the comparison across all the functions that are available on all three instruments. So to me, the accuracy of the MTR105 is a little bit lower than the U1461A. It's perfectly adequate for testing three-phase induction motors. Induction motors themselves, you've very rarely got specific manufacturer's data on them, so absolute accuracy isn't a pre-requirement. What's a requirement really is consistency of operation. And if you've seen the videos on I tested a rotor out with this instrument, you'll see this does give you erratic behaviour on the installation test function, whereas this instrument is perfectly fine. So it depends what your specific requirements are, but to me the accuracy of this instrument is perfectly adequate for its needs. One of the other issues with this instrument, of course, is its battery usage. It eats them like crazy. Megger do charger for it, and you can put some NIMH batteries in there. I have got the charger now, and it kind of does. Put that away. You can just about get all of the accessories that come with this into the pouch. If you kind of coil these up in a specific manner, you can fit the charger in there. There's the charger itself, plugs in at the top, and then you can plug power supply in. It is the same charger as Megger use on their MIT series, so if you already have that, it is compatible with the MTR105, but it does max out the case really. But all the accessories are fairly nice quality. I use the little mesh pocket for the probes and the grippers. I just then have the leads underneath the Velcro. Trying to get these leads and these leads here in and out of these pockets is a right pain. So to my mind, you could just do away with the netted pocket in this pouch. And it does just about zip up, but it is, you can see it's stretching the case as I do it up, so it's not the best, but you can just about do it. So for me, carrying the MTR105 around is a better option than carrying these two instruments around. I do want to do a bit more work on it because I have a lot of electrical transducers in the panels that I do with that give a 4 to 20 milliamp output, which this can't measure directly, but I'm going to do some tests with a load resistor and see if I can match the performance of either of those two instruments, which have built-in milliamp ranges and are much better for testing transducers than this instrument is at this moment in time. But I would say that the instrument is aimed more at motor rewind shops, manufacturers possibly, with the ability to do all those different tests on a motor sat on its own, not being connected to anything, and download them to a test certificate and issue that test certificate with the motor. That's quite a nice option for me. Coming from a maintenance perspective, which is where I work in, you tend to lose some of the advantages of the functions within the instrument. You take the three-phase insulation test to get the most out of it. You really have to disconnect the motor. That's not something I would generally do as a maintenance activity. You don't want to keep disconnecting and reconnecting motors just for the sake of testing. I would do all the tests from the panel, and in that manner I'd be testing the cable as well as the motor and get an overall picture. Again, the 4-wire function, that's really a test to be done direct at the motor terminals. Doing it from the panel, including the cable, you're usually into the ohms region, so you don't need the milliohms so much. But obviously it is there if you've got a fault on a motor that you want to investigate specifically. I've been asked for a copy of the test results, so I will load the file up onto the Element 14 website and do a blog on the MTR105 on that, and probably also the eevblog site as well. I'll leave the links to those blogs down in the description below so you can find all the test data. Yeah, so pretty interesting instrument. It'll be interesting to me to see if some of the other manufacturers, such as Fluke or Chavanonu, Sonal, maybe even Hioki, to say if they come out with anything that matches the MTR105 or the Gossen Metrawatt with its motor winding interturn test. So that'll be it for this video. Thanks for watching. Hope you found it useful. and I'll see you again in the next video.